Hi everyone! In this video I'm going to introduce you to the concept of the unit circle. And so the big idea behind the unit circle is that we're going to be thinking about angles now, not in terms of just angles within a triangle or within a shape. We're going to be thinking about angles in terms of rotations. And this is going to allow us to do much more interesting things with trigonometry. So previously with trigonometry, you were using sine, cosine, and tangent to solve for sides and angles and triangles. And that's fine. Like that's a useful use of sine, cosine, and tangent. But trigonometry is way more than that. Trigonometry involves any time you're involving the rotation of an object. And anytime you want to model the rotation of an object, you can do so with the sine, cosine, and tangent functions. And so if we're going to be talking about rotations, we need some sort of standard way of talking about angles. And that's the idea of angles in standard position. And we're going to do this on a regular Cartesian grid. And a Cartesian grid is just a fancy math language for your x and y axis that you're very familiar with. And what we're going to do is we are going to define 0-degree rotation to be the right-hand x-axis. Okay? So if you imagine starting from the origin and you draw a ray, of course is just a line that extends infinitely in one direction. So if you draw a ray that starts at the origin and goes to the right, then the rotation of that is 0 degrees, i.e. it's not rotated at all. And then what we're going to do is we're going to go counterclockwise from the x-axis. So if I draw a ray from the origin out to that angle, that's, 30 degrees maybe. And because that is 30 degrees back from the x-axis, 30 degrees counterclockwise. And so unfortunately, for various reasons, we want the positive values to be in the top right quadrant, and we want to start on the x-axis because x becomes before y. And so we're going to be doing counterclockwise rotations for all of our trigonometry. And so if we keep going with this, if you do all the way up to the y-axis, well, that is a 90-degree angle. And so the y-axis straight up would be a 90-degree rotation. And if we did a straight angle, like from here all the way across, how much would that be? Well, if we rotated a ray, right, going straight to the left, would be 180 degrees. And what about pointing straight down? Well, pointing straight down will be 90 to here. Another 90 brings us to 180. And another 90 brings us to 270 degrees, so straight down. And then a full circle then would be 360 degrees. So a full circle rotation would be like all the way around to here, which brings us back to our starting point. And so this point on the x-axis is both 0 degrees and 360 degrees. Right? Because a full circle rotation means that you're pointing in the same direction you started in. And in fact, you can keep going. You could go past 360 degrees. So let's draw another one to show what I mean for that. So let's say we've got, you're modeling the rotation of a Ferris wheel or something. This is the kind of thing we can do with sine and cosine functions. You could have things that spin multiple times around and around and around. So let's say you've got a Ferris wheel that spins 2.5 full rotations. Where would we draw that angle in standard position? Well, we start at 0 degrees, and then we're going to do one full circle. Will bring us to 360 degrees. And then another full circle from there will bring us to 360 plus another 360. Right, this is plus another 360 degrees. Brings us to 720 degrees. And I think I said 2.5 times, right? So then let's add another half turn to this. And a half turn would be adding another 180 degrees. So 0 full circle was 360, another full circle was 720, plus 180 to that means that this point here is going to be an even 900 degrees. And so this terminal arm here, we could also label as 900 degrees, because that would be 2.5 full rotations, which leaves you pointing in the exact same direction as the 180 degrees did over here. So that's the idea of angles in standard position. Now I haven't actually drawn a circle yet, so let's talk a little bit about the unit circle. We're going to get more into this in my next video where we talk about the lengths of arms of triangles and stuff. But in general, what we often care about is thinking about rotating around a circle. And the simplest circle that you can have is a circle with radius 1. So r equals 1. Now 1 is a unit. 1 is the basic unit, right? So this is why this is called the unit circle, because it is a circle that has radius of 1 unit. And we're going to be looking at angles going around, rotating along this circle. So let's say I've got an angle down here, right? What is the angle of that rotation around the unit circle? So we need to think about that in terms of starting at 0 degrees. We go all the way past 90, past 180, past 270, and let's say this is 30 degrees past 270. That would make this a 300-degree rotation, or something in that ballpark. I'm just sort of eyeballing it. So that's the big idea of the unit circle. Usually we're going to be talking between 0 and 360 degrees. But another thing just to think about is we could also think about this in terms of plus 360 degrees or even minus 360 degrees. So you could actually think of this also as a negative 60-degree rotation back from 0. And that would also be one way you could rotate to get to this position. And in fact, you can do minus 360 from 300 degrees to get your negative 60, right? This is how we got negative 60. Or you could do 300 plus 360, which gets you 660 degrees. And you could add another, add 2 full circles, which would be 720 degrees. And that would give you 1020 degrees, and so on infinitely, right? Because every single time you go around the circle, you're just going to add another 360 degrees. And you can add it as many times as you want and figure out another possible label for that terminal arm. And so because of that, because there's infinitely many rotations, just to keep us sane essentially, we're usually going to only talk between 0 degrees and 360 degrees. And that's the idea of rotations around the unit circle.